Today's daily code problem of the day is diagonal traverse number 498. For this problem, we're given an m by n matrix called mat, and we want to return an array of elements of the array in a diagonal order. So, pretty self-explanatory here in example one. We're going to use this diagonal pattern to traverse this matrix and add these elements in this diagonal pattern, right? So, um, actually, well, the numbers aren't in order, but we would go 1, 2, 4, 7, 5, 3, 6, 8, 9. So we're basically just going to hard code this solution. And to do that, we're first going to initialize the length of our array. And that array is going to be m by n. So first we'll define m and n. So int m will be the mat.length. And n will be equal to mat of 0.length. So mat.length is going to be from 0 to mat.length minus 1. And then this is going to be from 0 to mat of 0.length minus 1. Then we are going to initialize our result array. So our integer array result is going to be equal to a new integer array of m by n size, as specified over here, m by n. Next thing we're going to do is we are then going to identify a couple of variables that are going to help us traverse our mat as well as help us traverse our result array. So we're going to have an integer called our row. So this is going to keep track of what row we're looking at. We're going to have an integer called column, which is going to keep track of what column we're looking at. And then we're going to have an integer called our direction, which is going to keep track of which direction we're moving, whether we're moving up and right or if we're moving down and left. So in this case, direction is equal to 1 means we're moving up and right. When we are moving down and left, we'll set direction to be equal to -1. So we'll know down left is negative, up right is positive. Then we're also going to have one more integer here. We're going to have our integer idx, or our index, so we could just call it I, which is going to be equal to 0. So after initializing our base cases and our variables, we're now ready to jump into our loop, which is going to allow us to traverse the map and fill our result array. So it's going to be a while loop. So we're going to traverse this map while our index variable is within range, meaning that once we hit this point here, or m by n, we are ready to break out of our while loop. So we'll say once we reach this point, we'll break out of our while loop. And that's because when we hit 9, when we hit this final block, we'll go up, and then we'll go down to try and traverse again, but there won't be anything there because it'll be null. So we'll say while our I value is less than our m by our n value, we're going to be out of range then, which means that we have completed the mat. We're going to say our result of our I value, an increment I value after we set this, is going to be equal to the mat of row of column. So we're basically saying while we're in a valid range, we are going to set the result of whatever the I position is, and we're going to equal that to our mat of whatever row column we're looking at. And then I++ simply means after we set this position, we'll increment I to be the next value. Next thing we're going to do is move our pointers. So we're going to have to move our row and column as needed. So if we're moving up and right, or our direction is equal to 1, we are going to first check if we hit a boundary. So if our column is equal to n minus 1, that means we've hit the right boundary. So column is equal to n minus 1. We are looking somewhere in this far right column. Our next move is going to put us out of bounds. So we need to shift our value down. Now, the way that this works, or the way that matrices are labeled, are like this, because they're 0 indexed. So if we want to move from this position here down, we're going to have to increase our row count. So if column is equal to n minus 1, we're at the far right column, our row is going to increase. And then we're going to shift our direction to be equal to -1, meaning from now on, we're going to be going down and left, which is exactly what we want. Otherwise, we're going to check and see if we hit the top boundary. So if our row is equal to 0, again, because we're going up, the values are going to get smaller. So we hit the top boundary. In this case, it happens to be the right boundary and the top boundary. That's why we first check the right boundaries, because we need to shift down. But let's say if we hit this top boundary, then, and it's not the right boundary, we're going to have to go right. So we identified that we hit the right bound or the top boundary. Column is going to increase in this case, and then our direction is again going to be equal to -1. So if we're on the right boundary, we're going to go down. If we're at the top boundary only and not the right boundary, we're going to go right and then shift the direction to go down and left, just like that. Otherwise, if we did not hit a boundary, we could simply update our row and our column to go up and right. Now we're going to have to do the same thing for if we are going down and left. So because there's only two options for direction, either 1 or -1, we don't need to say else if. So we'll just say else and assume that we're moving down and left in this case. We'll say if our row is equal to our m value minus 1, or otherwise known as we hit our bottom boundary, we're going to increment our column by 1 and shift our direction to move up and right. So if we hit the bottom boundary, for example, here, we hit the bottom boundary, we're going to shift our row by 1, or sorry, our column by 1. So we're going to move to the right 1, and now we're going to go up and right, just like that. Now our other case, if we're moving down and left, so else if, is if we hit our left boundary, like we do right here with 4, we hit the left boundary. So instead of moving right, we want to move down. So otherwise, if our column is equal to 0, or our left boundary, our row is going to increment, and then our direction is going to shift. And then our base case is we're simply going to go row plus plus, column minus minus for our simple traversing, like down and left. This is down and left. And that's it. So if we return this, make sure I name that right. Yep. So if we return this, passes our test cases, and if we submit it, that is our solution. So thank you, and follow up for more daily LeetCode solutions.